All right, for this belt work, we notice that the a in the numerator, the base a, is not really being affected or operated by anything except the base b's. So if we apply the rules that we already know, we're not going to be applying it to the a. All right, so it's still going to be the numerator. But the b's, the base b's, I do have a 7 in the numerator, and then the 3 in the denominator. So between these two, since we're dividing the bases, we're just going to subtract those exponents, okay? So then this would end up being b to the power of 7 minus 3, which is 4. So over here we'll just, and that would, of course, stay in the numerator. We'll learn more about that today, which means I don't really need the fraction line. It's just a times b to the power 4. And then we've simplified that using the quotient rule that we've learned, I guess that was 2 times ago. So here's our objective for today. I know the value of anything raised to the power of 0, and I know that negative exponents reciprocate or flip values, at least when we look at them as fractions. So take a minute and copy that down, please. All right, just as a quick rule, at least for exponents of 0, and we won't see a lot of problems like this, not on the homework or the test, which is coming up. But in general, if you see a base, doesn't matter what the base is, it can be a number like 6. If it is raised to the power of 0, then automatically it is 1, right? And we'll explain why here in a second. But again, it wouldn't matter if it's a letter either. So if you had x to the power of, well, 0, it still is 1. Okay, anything to the power of 0 is 1. It wouldn't matter if this is in parentheses. It wouldn't matter if you showed it as a fraction. It wouldn't matter if it has decimals. Okay, anything to the power of 0 is 1 automatically. All right, so here's some rules that we've seen. Of course, they missed one, I guess, with this parentheses and, well, maybe not parentheses, but at least with the fractions. If you had x's and base x is being divided, which we saw in the bell work, but let's say you had a power of m and then n, we'll use the same letters they're using. Take that same base, but you take the two exponents, m and n, and since it's being divided, you would subtract those, okay? And this is really where 0 exponents come from, is subtraction, because if you start getting rid of exponents, then yeah, eventually you can end up with 0 exponents, or like the second part of the objective, with negative exponents as well. But remember, we know now that anything to the power of 0 is 1. Now just to expand on that, just think about how would you get an exponent of 0? Well, if we looked at an example, such as this one, let's use, I don't know, base 3's, I guess, 3, let's say 3 to the power of 4, all over, well, 3 to the power of 4, right? Now, we wouldn't have to do any math if we remember that anything divided by itself is 1 automatically, no matter what it looks like. But if we were to expand this, you'd say, well, you got 3 4s, 1, 2, 3, 4. You got 4 3s, there we go. And then they're all being multiplied. Same with the denominator. And anything divided by itself is 1. Now, these usually become phantom ones, but because we canceled all of them out, again, not really canceled, but crossed them out, then we end up with 1. Okay, well, how does that end up with the power of 0? It's because you had a base 3, you had a 4 in the numerator and a 4 exponent in the denominator. Since it was being divided, you'd subtract those exponents, and yeah, now you'd end up with base 3 to the power of 0. Now, this is the same thing we just did. We just did it twice in different ways. Right here, we actually expanded the bases and then divided. Whereas the second way here, we use the rule, and that's how we get that 0 exponent. So you get 0 exponents because really what's happening is that all the bases, 3's in this case, are getting crossed out as phantom 1's. So be very careful. The worst thing you can do on this is when you see something like 3 to the power of 0, you say that's 0. Okay, it is not multiplication. It is exponents, which is repeated multiplication. Okay. This is not equal to 0. It is not. Don't do it. It's 1. Anything to the power of 0 is 1. Okay? So that's a little background with why anything to the power of 0 is 1. Now again, this is just kind of a standalone thing right now. We see, well, anything to the power of 0 is 1, and that sounds good. However, these are going to be mixed in with other parts of the expression where we're going to be mixing the rules, these types of rules. It'd be nice if you ever see anything to the power of 0, just say, well, it's 1. And if the sooner that becomes instinct, the better off you're going to be, especially when we see them in bigger expressions, because then you just make those phantom ones. You pretty much get ignored. There's the rule. Again, and again, x right here is the base. It could be a letter, it could be a number, it could be a fraction, it could be lots of things. But if you take anything to the power of 0, automatically you end up with 1. All right, here we go. Here's some examples for us. And again, I really prefer these. If I saw a to the power of 0 on part A right here, again, the sooner this becomes instinct, the better off you're going to be. Anything to the power of 0 is 1. Done. All right. In fact, it'll work the same way with B. And yeah, they got parentheses. The parentheses don't really matter because it's something to the power of 0, 1. Well, C as well. Now this one does have parentheses. But remember, it doesn't matter if you have a fraction to the power of 0 or if there's decimals in here. It's something, and it is in parentheses, that's okay, but it's something to the power of 0 is 1. Same with D. This one tends to confuse people because it's got lots of stuff on the inside of the parentheses, but once again, it doesn't really matter to us because you have lots of stuff, all to the power of 0, yep, 1, automatic. Okay, so this answer is 1. See how nice that is? Again, if we could have all problems like this on the assignment, then it would be nice. But you'll see stuff like E and F as well. So E, now this one shows right here, it's a to the power of 0, which is okay. It's just if you find anything to the power of 0, that's a 1 right there. It's a phantom 1. Well, it's going to be a phantom 1, okay? So I got 1 right there, but this is where, yeah, I'm going to make it a phantom 1. Because it is 1 being multiplied by other things, so let's make it a phantom 1 right here, okay? So it went away. It's still there. It's more like you just can't see it. It's not that it's gone away. So now I can apply my exponent rules to this stuff, right? For my fraction, I've got base B in the numerator, C in the denominator. Now the base B has an exponent of 4. The C has an exponent of 1 right there. It's a phantom 1. So I'm going to show it. It's no longer a phantom 1. It's an actual 1. But the 2 on the outside of the parentheses, I need to apply that to both exponents on the inside of the parentheses. Since it is parentheses, though, it's going to be multiplication. So for base B, it'll be exponent 4 times 2. For base C, it'll be exponent 1 times 2. And now that I've got this down, I just need to simplify this completely. See if I can make that a little smaller, though. There we go. There's B and C bases. The new exponent for B, though, 4 times 2 is 8. And the new exponent for C is 1 times 2, which is 2. Now, if these were the same bases, I could continue operating with them, but they are not. So we're just going to keep it like this. B to the power of 8 all over C to the power of 2. But remember, over here, there used to be, what was it, A to the power of 0? So we just made it a phantom 1. Right? We just don't want to look at that garbage. All right, so part F. Now, I would operate on the inside of this, and what do I notice? Yep, there's a power of 0, x to the power of 0 right here. Okay? Now, I don't want to see that power of 0, which is 1, by the way. Anything to the power of 0 is 1. So, yeah, I'm going to change this into a phantom 1. Again, I can do that because it's all being multiplied. All the bases are being multiplied. So, now that that is a phantom 1, I will combine my bases on the inside of the parentheses, which means I'm not doing anything with the 3 on the outside here. But I do notice that my y's are the same bases, right? They're being multiplied right here. So, for the second y there, I see an exponent. I didn't see it, but it is a phantom 1, so I'm going to show it. Which means that since the bases are being multiplied, I can just add those 2 together. Okay, this is going to give me then a new base y with a new power 4 plus 1 is 5. So now I have bases of 3, x to the power of 3, and y to the power of 5. And yes, 3 does have an exponent of 1. It's a phantom 1 right there. Okay, why do I need that? It's because now I will apply the 3 on the outside of the parentheses, the exponent, this 3. All right, I'm going to apply that to all the exponents. And since we are looking at parentheses, I need to multiply that by all the exponents on the inside of the parentheses. Okay, so base 3 has an exponent 1 times 3, now 3. Base x has an exponent of 3, but now multiplied by 3 as well. In base y, exponent of 5, now multiplied by 3. So then I end up with 3, base 3, x, and y. But with new exponents, base 3, 1 times 3 is my exponent, which is 3. Base x, which has exponent 3 times 3, which is now 9. And base y has an exponent 5 times 3, which is 15. Now there's not much to do here. I can keep my bases pretty much the same, except my base 3. But the base x and y are going to keep my base, the exponent 15 and 9. But 3 to the power of 3, I can evaluate that. So I'm going to look at that over here. It's 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So this is the real answer I'm looking for on this one. Thank you. 27 times x to the power of 9 times y to the power of 15. That's the one I want. All right, negative exponents. And we've seen negative exponents before. In the example that we saw, I think it was like b to the power of 3 all over b to the power of 5. And from that example, remember, if you expand the b's, you'd have 3 b's in the numerator, 5 b's in the denominator, all being multiplied. And yeah, anything divided by itself was 1, so we get these phantom 1s, and then you get base b to the power of 2 in the denominator, but what did we put in the numerator there? It's that phantom 1 right there, okay? Now that's from expansion, and then kind of making phantom 1s if we need them. But it is possible to just use the rule on this. And yeah, you take the exponent of the numerator and subtract the exponent from the denominator. Again, it's subtraction because it's dividing the bases. And then we end up with b to the power of, now, 3 minus 5 is negative 2. These are the same thing. This is the same as this. It's the same exact thing. Okay. Now, what they want, what they'll say is, we don't want to see any negative exponents. So if you ever see something like this, all it means is you're going to change it into a fraction. Now, I say that, but it means that it used to be a fraction. In the objective, we said that it's reciprocated. All that means is that where this was in the numerator right here, even though it was dividing by phantom 1, if it's in the numerator, switch it to the denominator. Okay? So wherever you get negative exponents, just switch it from numerators to denominators or denominators to numerators. Which means if, by chance, you had an example like this one, something like 1 over, I don't know, x to the power of negative 2, all right? So that negative exponent, it can be changed to positive exponent if you just move the base from the denominator to the numerator. So then, see how that becomes a positive 2 right there? Now you could say that's over 1, but really we would just make that x to the power of 2. Okay? So negative exponents, all it's saying is just move the base from the numerator to denominator or denominator to numerator. Another clever way to remember this is if it crosses the fraction line, then change the sign of the exponent specifically. All right, for exercise 5, we got base 5 to the power of negative 3. And again, you could show this as over 1. So really, to make that a positive exponent, I'm just going to change it from the numerator to the denominator. And now instead of it being negative 3 exponent, it's positive 3. Now we do need something in the numerator, and that's where we're going to use a phantom 1 like this. Okay? So like the objective said on this assignment, if you wanted to flip them or reciprocate the fraction, you could. But it's only with that negative 3 exponent. All right, exercise 6. This one already has positive exponent, and 8 to the power of 9 is kind of big. I'm just going to leave it like this. This one may seem more tricky than it's supposed to be, but hopefully you know it's already got a positive exponent, so just keep it that way. All right, exercise 7 right here. This one gets tricky because a lot of students, again, they apply this negative 4 exponent to the base 3 as well as to the base 2. But the base 3 has an exponent of a phantom 1 right here, okay? So while we can look at this as a fraction over 1, I'm not reciprocating the base 3, only the base 2 because it has a negative exponent. So the base 3 will stay in the numerator. But to change the exponent for base 2 from negative 4 to positive 4, I'm going to have to switch it into the denominator. So then I get 2 to the power of, again, that's positive 4 now. And yeah, we can evaluate that. That one's not too bad. 2 to the power of 4. So that's 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So I get 3 over 16, and that'd be as far as I need to go on this one. All right, number 8. Again, if you see stuff like this on either assignment or pretty much anywhere, just pretty much ignore it, okay? But again, I got x to the power of negative 3. I want that to be a positive exponent, so it would be in the numerator right now. So if I switch it, though, from the numerator to denominator, the base, it changes the exponent from a negative to a positive. And yeah, we can put a phantom 1 there in the numerator just to show it. And that's good. Exercise 9, yep, it's already got a positive exponent, so that's as far as we need to take this one. I mean, if you could reverse it and say, well, x to the power of negative 9, that's true. It's just we don't usually want to show our expressions with negative exponents like this. Okay, so this would be completed for me. And then 10 right here, this one is just like, what was that, 9, 8, 7? Exercise 7, where students say, well, look, you got that negative exponent, so now it's xy to the power of 4 right here, and you get 1. This is not good. And again, the y is good, but the x, remember this x right here does not have a negative exponent. It has a positive 1 exponent right there. So instead of the x being part of the denominator, we need to get rid of it, it would stay in the numerator, like this. And this is actually our final answer right there. All right, exercise 11, we see base 19 is being divided, so I'm going to keep my base 19. But since they're being divided here, it means I'm going to take my exponents and subtract them. So I got a 2 in the numerator, a 5 in the denominator. When I subtract those, I get 19, but now to the power of 2 minus 5 is negative 3. But again, we don't want to see that negative exponent. So whereas this 19 base would be in the numerator, I'm going to flip it, so now that it is in the denominator. But it changes the sign of that exponent into a positive 3 now. And yeah, I'll just put a phantom 1 in the numerator. Now you could evaluate 19 to the power of 3. You could use the calculator for that, but I'm going to stick with this right here. Number 12, this is going to work the same way, right? We got a base 17 right here. And since the base 17s are being divided, we're going to subtract the exponents. The numerator first, the denominator exponent second. But you see how that's minus negative 3 right there? So it's not going to affect the base. But I do know that 16 minus negative 3, you could put that in the calculator if you need to. You're still going to get 19. It's a pretty big number, so I'm going to leave this one like this as well. Yeah, we can leave it like this because it's already got the positive exponent, which is what we want. All right, so we've done this before where we've mixed the rules up. And this one, oh yeah, it's got this, it didn't show it, but it's got this x to the power of 0 right there. Yeah, now we're seeing some of the negative exponents and some exponents of 0 combined with some of our other properties, multiplying, adding, and subtracting the exponents. Remember, you'll get into dividing exponents in ninth grade, but for now it's not what we're going to go over. So x to the power of 0 right there, I know that's a 1, but once again, I can change that into a phantom 1, which is nice. So then I don't have to look at that garbage, okay? Now, if I was doing this problem, what I would do is I would look first to start simplifying my numerator, all right? So that means, and why the numerator? Well, it's because I've got this exponent of 8 with this set of parentheses. So I need to do this multiplication before I start operating with any of these bases in the denominator. So I'm just going to focus on simplifying my numerator first, and then we'll see how it affects the denominator stuff. So I've got a base negative 3, and I do need that in parentheses because the negative 3 here is in parentheses as well. I've got base h, x, and y. Now to identify the exponents, the base negative 3 in parentheses, that has an exponent of 1. Same with the base h has an exponent of 1. The x and y had exponents of 2 and looks like negative 3. But again, this 8 on the outside of that parentheses, since it is parentheses, I need to multiply this 8 exponent by all the exponents on the inside the parentheses. So that'd be negative 3 base to the power of 1 times 8, h base to the power of 1 times 8, x base to the power of 2 times 8, and y base to the power of negative 3 times 8. So this allows me to further simplify this numerator. I still got the same bases for now. Negative 3, h, x, and y. We're not changing the bases, but we are working with the exponents. Base negative 3 in parentheses, 1 times 8, that's my new exponent, 8. Base h, exponent of 1 times 8, which is 8. Base x to the power of 2 times 8, which is 16. And base y to the power of negative 3 times 8, which is negative 24. All right, so that does simplify the numerator. Now, some of you may keep that denominator exactly the same way as you see it. But I'm going to start simplifying it right now because I see the same bases being multiplied, and so we can start operating with those, all right? So I'm looking specifically right now at my base 3's right here. That's 3 times negative 3, which is negative 9. I've also got base x's and base y's. Now everything's being multiplied right now, so I can take my exponents. Let's start with the x's. X's has exponents of negative 4 and 6. And since everything's being multiplied, we're going to add those two together. And then the base y's have exponents of 5 and negative 7. But again, since the bases are being multiplied, we're going to add those two together as well. Okay, so we've already operated with those 3, so I still have negative 9 here. But my base x's and y's are going to have new exponents. So base x, exponent of negative 4 plus 6, which is 2. And then base y with the new exponent, 5 plus negative 7 is negative 2. So now that I've simplified that, I can actually pretty much just ignore everything that we've done and just start operating with what I have now. Okay, so it's a matter of being able to focus on one part at a time, which we've done. We focused on the numerator first and then the denominator, and that's given us a new expression to simplify. So right here, I would be looking at first my numbers. So that's a negative 3 to the power of 8 all over negative 9. And what I'm going to do is I'm going to put this into my calculator. So I'm going to put negative 3 to the power of 8. Let's see what we get on that. 3 to the power of 8. This is 6,561 all over negative 9. Now I'm going to put this into the calculator. Divide that by negative 9. That gives me negative 729. Okay, so that would be over 1. So that negative 729 is going to be part part of the numerator, like this. And remember, if you're looking for the exponent button, it looks like this. It's one button to the left of 7, and then one up. And yeah, you'll need to use parentheses on that -3, otherwise it may give you a negative answer, but it's not. It would be positive 6,561. Now, we have this h to the power of 8 right here. Nothing to operate with it, or nothing to change it with, so it's still going to be just h to the power of 8 in the numerator. But I can look at my x's, my base x's. I got x to the power of 16 in the numerator, and I've got x to the power of 2 in the denominator. I can operate with that. Since it's being divided the same base x, I'm going to take my two exponents, 16 and 2, and subtract them. So that now is x to the power of 14. And since it came out as a positive exponent, it's going to stay in the numerator. X to the power of 14. But then I've got my base y's. And I've got a y to the power of -24 in the numerator. Y to the power of -2 in the denominator. So again, these are being divided, the bases, base y's. So I'm going to take my exponent from the numerator, -24, and subtract, because it's being divided, the exponent from the denominator. So that's -24 minus -2, which will be base y to the power of -22. But again, we don't want that negative exponent, so while this would be in the numerator over 1, I'm going to switch it to the denominator, and that changes the exponent to positive 22. Now you could look at this as 1 over y to the power of 22, but I just want to acknowledge that this is in the denominator, so it needs to stay in the denominator. I don't really need to show the phantom 1 anywhere in the numerator. Now we can double check here at the end. I don't see any other bases to combine. So this is it. That's done.